Hi everyone, thank you guys so much for tuning into this quick tutorial on how to use this Portfolio Optimizer Excel spreadsheet. So this spreadsheet is here to help you guys figure out the optimal weight of various securities in a portfolio. And it does this through looking at various variance statistics and using the efficient frontier model popularized by Markowitz. So when we're doing the efficient frontier, you either have a certain variable of risk that you guys are wanting to achieve, or you want to pick the variable with the smallest amount of risk and the highest return. So returns usually kind of make this boomerang shape, and you want the one kind of here at the tip. So this whole spreadsheet is developed to help you guys find that using Solver. So what we're going to do is so over here we have an input section where you guys, and actually I'll highlight that later. So you guys can input in the names of your securities. So you could just write security 1. And everything's linked, so if you enter it here, it will change here, 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 and here. So that's what so first you enter the name and then skip over this output section right here for the optimal weight, because that is what we are going to solve with Solver. And we're not quite there yet because we just entered the security names. And over here we're going to enter in the statistics. And so mean, this is also the average annualized returns. So I'm going to write returns / mean. And the standard deviation. And I hope you all know very well after your M5 assignment how to find the annualized average returns and standard deviation for a data set. And unlike Module 5 homework, you guys can just do this on a shorter year period. You don't have to do since inception. Just make sure you're consistent with all of the funds. So these numbers right here, you guys will enter in, and I just entered in some dummy data, and I've actually changed them quite a few times because I tried to record this a lot, and I don't know, I thought it was silly, and when I was changing the data, all of the data changed. So I'm going to leave this right here because I know that everything is working out. So yeah, we entered the names, the means, and the standard deviations, and you will also have to enter in the correlation. And remember, correlation, we use the Correl function in Excel, and this is through the returns. When you're finding the mean and standard deviation, also find the correlation. And correlation, it is important to put it in a table. So security 1, and remember the correlation of an investment with itself is always 1. Or just like any data set 1 and data set 1, correlation is 1. So that's why REIT 1 correlated with REIT 1 equals correlation coefficient of 1, and so forth. And you guys just have to enter in these numbers up here. And this is just randomized data that I had and then hard-coded in. But like I said, you guys will change these values. And then that's all of the entering work for you guys. Well, of the entering the regular data so far. You guys do have a little bit more entering in, but almost done. So then we're going to go down to this covariance table, and I went ahead and copied or pasted in the formula for covariance, which, as you see right here, it's actually a very simple, short formula, which is amazing, always nice, and especially once you do this exercise, I'm sure you all will definitely remember this formula. But so this right here, the first part of the formula is the covariance between dataset 1 and dataset 2 times the standard deviation of dataset 1 and the standard deviation of dataset 2. So this is all coded in here for you guys. Oops, if you pull it up, you can see, yeah, there we go. So this one you only see 2 items highlighted because you are doing the standard deviation of security 1 and standard deviation of security 1. So you do it twice, which is why you only see 2 boxes highlighted, times the correlation, which is right here. And I'm going to exit because I'm not going to touch the data anymore. So we found the covariance table, or that's how it's calculated. And then, so these are the numbers we want to find out, the optimal weight of the securities or assets in the portfolio. So we're almost there. I know I keep saying that, but we're almost there. So another thing we have to set up is, and this actually should just auto-populate, but so this is the weight times the return, which is the annualized returns, which are the means. So as you see, this one's highlighted, and then it's multiplied by the weight that is going to be calculated from Solver. So we do that for all 5 of our assets, and at the end we take the sum, and it's just the weighted average return. So that's the portfolio mean, or just the weighted return. And this will be the return that we receive from the portfolio because it's the weight of all the individual assets returns and then added together. And then we're also going to, or Excel is going to take the weight of the covariance. And this is a lot of clicking. So I already did that for you guys. So we take the optimal weight, which is found again by Solver, times the securities covariance, and then we just add it for each one. And I put them in parentheses just because it's a little easier to break it out. So yeah, we have security 1, the optimal weight. Yeah, so that was fun to fill out. And then we also have the weight of the weighted covariance, which is right here, which is nice, easy formula. Just multiply this by the optimal weight. And then over here, we sum it, and then that gives the total portfolio variance. And again, like the portfolio mean, it's just the weight of all the individual securities up here, and then added together, which creates the total portfolio variance. So we finally have almost everything good to go. And so we're going to talk about how to get Solver to find these variables for you. And I wrote them out up here. So the target cell is going to be the portfolio variance, which is right here. It's this orange color. And we want to minimize that because remember, with the efficient frontier, we want the least amount of risk that we can get. And then the cells to change, that would be the optimal weight right here. And then, oh, sorry, constraints, not constraints. There we go, constraints. So we want all of these numbers to be greater than or equal to 0, the numbers that we're changing. Again, the optimal weights right here. And so I have done this portfolio optimizer quite a few times today, and I did have trouble at one point when I just entered them in as an array like this, where I just highlighted them all and then did greater than or equal to 0. I have had that work before in Excel, so I'm not really sure why, but I remedied that by just entering each cell individually as greater than or equal to 0. So this one greater than or equal to 0, C24 greater than or equal to 0, and so on. And we're almost done with the constraints. Portfolio mean is right here, and we want it to equal the input target mean. And so to get all of these numbers, you are going to give Solver several different means, and then it will result in the portfolio variance. And I just set this up like this because it's easier to graph. You just highlight it and click go. So it's all about trial and error. So this is from some data I did earlier. As I was filming the earlier tutorial, I changed all of the data. So this is, these figures right here are not exactly accurate, or for the current data, but it's changed a lot. So I'm not really sure. Should have used real data. just to make sure everything equals out. But you can also, if you don't want to plot, you can always figure out the optimal means and standard deviation by, if you look right here at these standard deviations, you see, so before 18 in this data set that we had, they are going 22, 21, 20, 0.65, and then here we have 20.57 and then 20.59. So this is the smallest number, and as you see, it goes 57 to 59, whoops, sorry guys, to 96. So you can see this is this kind of like creating this parabola shape right here. So these would be the numbers you would choose to get this point right here. But yeah, so to use Solver, what you do is, so you enter all of these in, and you don't have to do this many. I just did way too much data, and I figured I would just leave them there. But since I changed all the data, we're going to start with 6%, and so we're going to put the input target mean, and then Solver is going to figure out the optimal weights to work with this and this and this to give us these numbers. So if the target mean is 6, and we can just put this here too, just 6%, then we're going to put it here, Solver. Okay, again, here are all the constraints, and they're in the Excel, so you can look over them a little bit better. And we're not doing any short sales, so we don't want any negative numbers. Solver found a solution. So we're going to keep Solver solution, click OK, and that is what gave us these numbers right here. So you see these all add up to 100%, 1, and what we would do is we would put 0.0033%. Actually, I guess I can edit these, and then so 6.5, and then you would run Solver again. So we'll just go ahead and put 6.5, Solver, whoops. Oh, there we go. Sorry, I'm not sure what that was doing. Okay, Solver found a solution. Perfect. 0.0034. 0.0034. And yeah, these are extremely small standard deviations. This is not a super risky portfolio. We're going to do 7.0. Actually, I'll go ahead and move this for you guys. Home. Oops. 7. Okay. So we have the input target mean as 7. Now we're just going to go back to data. Solver. Looks good. Solve. Keep the solution. And let's see. 0.0035. All right. Oh no. Yeah, sorry. So when you enter that as a percent, it should be that. Okay, perfect. And you just do that until you get this efficient frontier parabola that I did with some other data. So when I send it to you guys, I'll take off these top ones, but that's essentially what you do. You plot it out, you get this, and yeah, you pick the one with the lowest variance and the point right there on the efficient frontier. So feel free to ask any questions if you guys have them, and yeah, happy to help. Have a good week. Thanks so much.